All right, let's get right into it. For years, physicists have been on a quest for a theory of everything. That one single idea that could finally connect gravity with the weirdness of the quantum world. This has led us down some amazing rabbit holes. We've got string theory, which talks about tiny vibrating strings in extra dimensions, and loop quantum gravity, which imagines spacetime as this kind of quantum fabric. But today, we are going to explore a completely different idea, something called single point theory. It doesn't need extra dimensions or super complex math. Instead, it suggests that everything we see, all of it, comes from just one unbelievably simple rule.
So, what is this rule? Well, the theory starts by asking you to throw out one of our most cherished ideas, the Big Bang. Forget the chaotic, hot, dense explosion. Instead, I want you to imagine the universe kicking off with a single, repeating process, a fundamental rhythm, a beat that literally generates reality, one frame at a time. And this idea is at the absolute core of single point theory, or SPT. It's called the primary cycle. You can think of it like the universe's ultimate refresh rate, ticking away and building what we call existence with every single tick. And get this, it isn't happening inside space and time. This cycle is what creates our experience of space and time. And the speed of this thing, it's just insane. The theory proposes it's happening at what's known as the Planck frequency. That's a 1 with 43 zeros after it, cycles per second. To put that in perspective, that's the absolute fastest that anything can happen according to the laws of physics. And SPT says this isn't just some theoretical limit, it's the engine of creation itself.
Okay, but that's a huge question, right? How in the world do you get from a simple repeating beat to the incredible complexity of our universe? Well, to get there, we have to zoom out and see what this cycle looks like on a much bigger scale. So if you could zoom out from those individual, impossibly fast ticks, a kind of fabric would emerge. SPT calls this the process field, and this fabric has two really important properties. The first is amplitude, which is basically the local energy density. The second is phase, which is the local rhythm or timing of the cycle. And as you'll see, everything, and I mean everything, comes from the way these two things interact.
So, how does this abstract field create actual, tangible stuff? This is where the theory gets, well, really beautiful. It says that things like particles and forces aren't fundamental things at all. They're just stable, persistent patterns, like little whirlpools or vortices in this process field.
Think about an electron. In this picture, it's not some tiny little ball. It's a stable, self-sustaining whirlpool, a pattern that just keeps going because its internal rhythm is perfectly in sync with the field around it. It's a huge mental shift, Existence isn't about being a solid thing. It's about being a persistent pattern.
So if particles are whirlpools, and what are forces? Well, SPT says they're just the geometry of the field itself. Imagine the field's amplitude, its energy, is like a rubber sheet. A massive object creates a big dip in that sheet. The steepness of that dip, its curvature, is what we feel as gravity. Now imagine the phase, the rhythm, gets twisted and out of sync from one point to another. That twist, that torsion, is what we experience as electromagnetism. Just like that, two of the fundamental forces of nature become just different shapes in a single underlying field.
Okay, this is all a really cool story. But is it actual science? To figure that out, you have to check if it makes predictions we can test. And there's really no better testing ground than the simplest, most precisely measured thing we know of, the hydrogen atom. To do this, SPT uses a mathematical toolkit called the hyperbolic vortex model, or HV model for short. It takes all those core ideas we just talked about, the field, the vortices, and applies them directly to the electron in a hydrogen atom, treating it like a stable whirlpool spinning around the proton.
So how does it do? Honestly, the results are pretty jaw-dropping. The model's prediction for the binding energy, it matches the official value from NIST perfectly. Its prediction for the orbital frequency, an exact match. And it nails the de Broglie condition. That's the rule that makes sure the electron's wave fits into its orbit to within less than 1 part per billion. This isn't just in the ballpark, it's a dead-on bullseye.
And this shows it's not a one-time fluke. The HV model perfectly reproduces fundamental physics that we've known about for a century. This gives the whole theory a really solid grounding in real-world experimental science. It's not just a cool idea, it's a predictive machine that actually works. But here's the thing. To be a really compelling new theory, you can't just get the old answers right. You have to make a new, unique prediction that nobody else has made, something that could, in principle, prove you wrong. And this is where SPT takes a huge leap into brand new territory. So let's look at this really tiny quantum effect called the Lamb shift. The standard model of physics explains it with this idea of virtual particles constantly popping in and out of existence in the vacuum. SBT has a totally different explanation. It says the effect comes from the vortex's own internal energy, an effect of its deep down structure. And this different way of thinking leads to a pretty wild prediction. And there it is. SPT predicts that a hidden parameter in the theory, this critical energy scale called EC, isn't actually a constant. It changes based on how much energy you use to look at a system. And it follows this very specific scaling law. It's proportional to the probe energy to the power of 1.5. Literally no other theory in physics predicts anything like this.
So what does that equation even mean? This quote here is a great way to picture it. It means the vacuum itself has a kind of stiffness that changes. If you poke it gently with a low-energy probe, it's sort of soft. But if you hit it really hard with a high-energy probe, it becomes incredibly stiff. They call this the curved wall. And it explains why we haven't seen these effects before. We were looking for a wall that stands still, not one that moves when you push on it.
And here's the kicker. This scaling law isn't just a wild guess. The data actually confirms it. Using one experiment as a starting point, the law predicts the critical energy for another experiment should be 89 million electron volts. And that's a perfect match. For another, higher energy data point, the prediction is off by less than 1%. It looks like the curved wall is actually real. This chart just makes it so clear. A low-energy measurement, like from an atomic clock, sees a wall at around 62 million electron volts. But then you use a high-energy X-ray, and that required energy just skyrockets to 1.6 trillion electron volts. The wall curves up, steep and fast, hiding these new effects from most of our experiments, exactly like the theory says it should. So where does all of this leave us? Single-point theory starts from this place of incredible simplicity, and it builds a framework that not only gets known physics right with stunning accuracy, but also makes this unique prediction that appears to be correct. The goal here is pretty ambitious. It's a shot at a complete theory of physics. Let's just quickly walk through that logic one more time. It's so clean. Step 1. You start with one rule, the primary cycle. Step 2. This gives you the process field, the fabric of reality. Step 3, from the geometry of that field, you get particles and forces. And step 4, this whole setup leads you straight to testable predictions you can check against the real world. And the potential here is just huge. Its principles could offer new ways to look at some of the biggest puzzles in science. For example, it suggests the Pauli exclusion principle, the rule that says two electrons can't be in the same state, isn't some weird abstract quantum rule. It's just a traffic law for vortices, a simple rule that says two whirlpools can't get tangled up in the same way. It offers a new lens for everything from quantum measurement to how stars work. This is a pretty great summary of where things stand right now. On the one hand, the theory's foundations, the parts that have to agree with a century of known physics, are 100% solid. On the other hand, its totally new predictions are still in that exciting phase where they need more and more experimental tests to really lock them down.
And that really brings us to the final, fascinating question that SPT puts on the table. For hundreds of years, we've argued about the true nature of reality. Is it made of particles? Is it made of waves? Single-point theory suggests a third option. Maybe it's neither. Maybe reality is simply a persistent pattern, a resonant whirlpool in a deep underlying field, and everything we see and feel is just a consequence of its shape. A whole universe born from a single simple beat.